Hi, welcome to the 5G NR Industrial IoT demo. My name is Mehmet Yavuz, and I'm a VP of Engineering at Qualcomm. In the industrial IoT space, a lot of big changes are happening recently, which are driven by big data, analytics, and robotics. Some people call these changes as the next industrial revolution or Industry 4.0. In this demo, I will show you how 5G NR can be used in industrial automation, and we'll show high-speed rotating disks which are controlled through actual industrial equipment. And I will show you 5G NR compared to the actual Ethernet cable connectivity. Here I will show you our prototype system with 8 rotating disks on the front, as you can see, with flashing LED lights behind. On the bottom, you can see the 5G NR prototype system. When we go to the side view of the proto setup, you see the motor drives controlling the rotating disks on the front. And these are all connected and controlled to the industrial motor controllers. And then on the top, you will see the industrial switches and logic controllers. We're using Profinet switches, which is a leading industrial standard for automation. But on the left side, we replace the cable with wireless. In the demo, I will show you the performance of wireline connectivity with respect to the wireless connectivity. Next, we're showing how the industrial control system is working through a simplified animation. You can see 8 disks with a hole in each of them. When we zoom into one of the disks, you can see it is connected to an industrial motor controlling the rotation. We also have one LED light behind each motor at the 12 o'clock position. As the disk rotates, the position of the hole is monitored by industrial control system, and when the hole comes to 12 o'clock position, LED is turned on momentarily. This is achieved by industrial motion controller and logic controller from Siemens that I showed earlier. Disk positions and commands are sent very frequently, hence the delivery needs to be fast enough. As part of this demo, we will show you Ethernet cable connecting the logic controller and motion controller can be replaced with 5G NR. Now back to the real demo setup. You can see here all the 8 disks are on 12 o'clock position and LED lights are blinking behind them. First, I'm showing you the precise motion control capability of the disks. Since the LED lights are fixed at the top position, we can only see the LED light blinking when the hole is at the 12 o'clock position. Here we show the GUI. On top, we are showing the measurements of the time offset between the LED turned on and disk being at the right position. On the bottom, we show the angular offset between the two. Now we start rotating the left 4 disks connected over the Ethernet wire line at 150 RPM. Now we go to 600 RPM rotation speed. Since Ethernet has only 1 millisecond latency, you can see that even at that very high speed, the holes are aligned with the LED lights flashing. These vertical green lines show actual measurements from the system. In terms of time alignment, you see that Ethernet is able to achieve 1 millisecond time alignment. Now we have the wireless system controlling the disks on the right side with 20 millisecond latency. Here you cannot see the LED lights flashing anymore because, as you can see from the GUI, there's significant delta in terms of the time offset. Next, we replace the wireless link with a 10 millisecond latency wireless link. Even now, you still cannot see the flashing lights on the right side. Looking at the GUI closely, we can see the red lines showing that the time offset is about 10 milliseconds, but still much worse than the green lines of the Ethernet wireline. Here, the most interesting part starts, which is the 5G NR, where you can see the LED lights blinking because 5G NR can operate with sub-millisecond latency and provide very similar performance to the Ethernet wireline. Here, blue lines show the actual measurements from the disks controlled over 5G NR. We see that both Ethernet wireline and the 5G NR wireless system works very similar. So what does this all mean? If you look at the factories of today, there are a lot of equipment connected over wireline, and the robots and the assembly lines are fixed. In the factories of future with wireless capability, the assembly lines can be reduced, there can be fewer robots doing more work, and they can coordinate with each other and work in collaboration, as you can see in this simple animation.